All right, so we're going to start with the second part of A4, so we'll finish that up, and then we'll start the first part of section 5.3. So yesterday we talked a little bit about I. Okay, I tried to explain how when we use I in math, it doesn't represent a variable. It is a letter from the English language, but it represents a number. Okay, the number that it represents is the square root of -1. Now, if that's I, does anyone remember what we said I squared was? -1. Yep. So what that means is because I squared comes out to a next number, anytime we're left with I squared, you have to change that to -1. Okay. So don't leave I squared in the final answer to any problem. As far as anything with a higher power, you're not going to have to worry about I cubed or anything like that. Just I squared is the one we have to focus on. All right, so we did addition, we did subtraction. Now we're going to look at multiplication and division. So multiplication. Let's say we had two complex numbers. Each number is going to have a real and an imaginary part. When you multiply them together, it's just like you would multiply with the distributive property. That's exactly what it is. So we multiply, if you want to think of it as like a pattern, some people think of FOIL. Multiply the first, then the outer, then the inner, and then the last. Some teachers don't use FOIL, they don't like that because when you do distributive property, it only works if you have two things here and two things here. Right? But that's all we're ever going to have. So it works fine for the examples I'm going to give you. But no, in general, FOIL doesn't work for more complicated kinds of problems. That's not an issue for us. And what's going to end up happening when you multiply the BI times the DI, you're going to get an I squared there. So that's the part where we have to remember to change that to -1. Right? So let's try some examples with multiplying. So here's our first one. 2 plus I times 1 minus I. Okay, if we follow the pattern that I explained up above, what would be the first two things you multiply together?
2 and 1.
Yep, 2 times 1. Let's start with that. 2 times 1. So that gives us 2. What would be the next two things?
The 2 and the -I.
Yep. So we're going to do 2 times -I. And what's 2 times -I?
-2i.
Yep. Just write -2i. Right. So we did the first. We did the outer. How about the inner? What's 1 times I?
I.
Yep. Just I. And now the last part is the 2 that are at the end with the I. 1i times -1i. Well, first, what's a positive times a negative? So we're going to have a negative. And what's I times I? I squared. Okay, so we've multiplied it out. There's a few things we have to combine together. First thing we can do is -2i plus 1i. What's -2i plus 1i?
-1.
That's -1i. So you could put -1i, you can just put -i, same thing. And then this part at the end, we've got minus, and what did we say I squared is? That's a -1. So I copy down the minus, and then I changed I squared to -1. So I've got 2 minus I. What happens when you subtract a -1? Yep, you're going to add it. And now we've got 2 more like terms to combine. 2 plus 1 gives me 3. So that's the final answer, and that's how you write it. When you write it, always put the real part first, and then put the imaginary part second. All your answers should look like this. Could be a plus or it could be a minus between the A and the B. It just depends when you combine like terms. In this case, it was a minus. Okay. Any question on that first one? All right. Let's try another one. So this time we've got 8 plus I times 3 plus I. Madison, what's the first two things I would multiply?
8 and 3.
8 and 3, and that gives me 24. Okay, Jaden, next two.
Wouldn't it be plus 8i?
Yep, so we're going to do 8 times I. That gives me plus 8i. Remy, how about the next two after that?
I and 3.
Yep. So I
Eight
times 3.
I.
And how much is that?
3i.
3i. And Serenity, the last two things we multiplied together are I times what?
I.
Yep, I times I. And that's a positive times a positive, so that's a positive. And what's I times I?
I squared.
I squared. Okay, so now we'll combine any like terms we can, and then fix I squared. Gianna, is there any terms that can be combined together there?
The 8 and 3,
And what would you get when you combine those?
11,
Yep, so we'll combine those and we get 11i.
and then the I squared becomes -1.
Yep. So again, try to make my ones look different than i's so we don't mix those up. So 24 plus 11i, and then we're going to change the I squared to -1.
So it would be 23 plus 11.
23 plus 11i. Always real part first, imaginary part second. Okay. Any question on that? All right. And the way that you know this problem is multiplication and not addition or subtraction is you look at each number. They're in two sets of, well, the one on the left is in a set of parentheses, the one on the right has parentheses, and there's no symbol between the parentheses. Parentheses are right next to each other. So even if there were no directions on this problem, you should be able to look at that and know that it's multiplication. So when we write complex numbers, in general, the letter they usually use in math to represent a complex number is Z. It's just the letter they use. So let's suppose that we have a complex number. I'm going to call it Z. And that complex number has a real part to it, and it has an imaginary part. When we do a problem, you'll know what those A and B actually are. Has anyone ever seen that symbol? Z with a bar on top.
Yes,
Yeah?
I've seen it.
Seen it? Yeah, there's sometimes you put different symbols above letters and it means certain things. Well, when we put Z with a bar on it, it's pronounced Z bar, Z bar. And that symbol stands for the conjugate of your complex number. Okay, so I've got to explain to you what conjugate means, but I'm just telling you right now what the symbol is. That is the symbol for what is called a conjugate. Does anybody know what a conjugate is?
I'm going to guess something with trigonometry.
Not necessarily trig. It's
Something with math.
something with math. Yep, it does have something to do with math, but it doesn't have to be trig, but it can be used in trig. We're not using it in trig. So the conjugate of a number means if your original number had a plus for the imaginary part you make it a minus. If the original number had a minus, you would make the imaginary part a plus. So all you're really doing is changing the symbol that's in the middle. If it's a plus, make it a minus. If it's a minus, make it a plus. So the short way to say that is you negate the imaginary part. Negate doesn't mean make negative. Negate means make it the opposite of what it is now. And the real part, you don't do anything to. So the A stays exactly the same. It's just the symbol in front of the B. Okay, so let's look at a few numbers and see if we can identify the conjugate. And then I'll show you what the conjugate actually is used for. Okay, so here's a complex number, 3 plus 4i. And in this column, I'm asking for the conjugate. What would be the conjugate of 3 plus 4i?
3 minus 4i.
Yep, 3 minus 4i. And something interesting happens if you multiply that number and that number together, and we'll do that after. How about negative 8 minus 2i?
Negative 8 plus 2i.
Negative 8 plus 2i. So that's the conjugate. How about 5i? Negative 5i. Okay, so think of it as, if you want to imagine there's like a 0 here. It's 0 plus 5i. The conjugate is 0 minus 5i. Or just negative 5i. How about 3? Conjugate is 3. Okay. If you're wondering why that one stayed the same, think of this as having plus 0i. The conjugate is 3 minus 0i, but that's the same thing. So any question on finding a conjugate? All right, now we're going to look at what happens when we multiply a number by its conjugate. So we're going to do one more multiplication problem. It's just going to be a very specific kind of special problem. All right, let's do 3 minus 4i. Okay, so that's the number we're going to start with. 3 minus 4i. And now I'm not telling you what the conjugate is. You have to figure that part out. So what are we going to multiply this by? Right, it says right here, multiply by the conjugate. And now let's FOIL that out and see what happens. Okay, I already know it's going to be 25. And I can tell the answer is 25 by doing something very quick in my head. It's a trick that only works if I multiply conjugates together. And I'll show you the trick after. All right, so let's start. 3 times 3 gives me how much?
9.
That gives me 9. What's 3 times 4i? 12i. What's 3 times negative 4i?
Minus 12i.
Minus 12i. So that's going to cancel out. And that's why I made this pretty easy to do in my head, because I knew half of the steps were going to disappear. 12i minus 12i. Right, and now the last part. Well, it's a negative times a positive, which is a what? It's a negative. And what's 4i times 4i?
16i squared.
So it's a negative 16i squared. That's gone. Now what did we say I squared is?
-1.
It's negative 1. So it's 9 minus 16, but it's 16 times negative 1. What's negative 16 times negative 1? That makes it a positive 16. And what's 9 plus 16? 25. What kind of number is 25? Thinking about those number system diagram from yesterday. It's what? Yeah, it's a counting number, and it's part of the real number system. It's not an imaginary number. So anytime that you multiply a number by its conjugate, all the i's will disappear. That's what happens when you multiply conjugates. if you multiply conjugates and you have an I in the final answer, you did something wrong. Okay, the I should always disappear. So how did I get 25 just by looking at it quickly in my head?
4 times
Well,
4 plus 3 times 1.
yeah. All you have to do is take this first number and square it. So 3 squared is 9. Take the second number and square it. 4 squared is 16. 9 plus 16 gives you 25. And if you're like, well, should you take the negative with the 4 or just the 4? It doesn't matter. Because when you square it, that negative goes away. So you square the first number, square the second number, add them up, and that's the answer. So let's see, do I have one of those? Yeah. So trying that shortcut, what would I get if I did 5 plus 4i times 5 minus 4i? What would be the two numbers I had together?
25 plus 16.
25 plus 16, which would give us how much?
41.
41. Yep. Okay, so that's a nice trick if you have to multiply conjugates. It doesn't work if the numbers are not conjugates. Then you just got to go back to doing the whole FOIL. But for conjugates, I'm going to use that trick in the future to speed things up. Okay. Any question on that? All right, so what do we use the conjugate for? So the conjugate is used when we are dividing complex numbers. The reason we need conjugates is because you're not allowed to leave an I in the bottom of a fraction. So we need a way to get rid of I. Well, we have a way to get rid of I. If you multiply by a conjugate, you will get rid of I. So that's where we're going to use this. So in order to divide two complex numbers, that's how you do it. Take what you're trying to divide, and you're going to multiply the top and the bottom by the conjugate of what's in the bottom. Now, when you have a fraction, as long as you multiply the top and the bottom by the same thing, that's fine. You can always do that. We're just multiplying by a very special thing in the top and the bottom that causes the i's to cancel out. All right, so we'll try 2 division problems, and then that'll finish up the first part of what we're doing. All right, so they want us to divide 1 by 3 plus 4i. Okay, the problem with that, it's kind of like leaving a square root in the bottom. Okay, we're not allowed to leave it. We're going to fix it so it's not there. So the directions say multiply the top and the bottom. Top and the bottom by the conjugate of the bottom. What's the conjugate of the bottom?
25.
Conjugate is 3 negative 4.
Well, what's the conjugate?
3 minus 4.
Right. Conjugate is 3 minus 4i. And now when you do the bottom out, what do you get?
25.
That's 25. 9 plus 16. Now in the top, that's just something we need to distribute, but it's only a 1. So what happens when I distribute the 1? Nothing. In this case, it doesn't change. If it was not a 1, it would change, but it is a 1. So the top is going to be 1 times 3 minus 1 times 4i. Now, we're pretty much done. The only problem with that is it's not written like this. When you write a final answer, you cannot have one big fraction. You've got to have your real part over here, imaginary part over there. So this is how you fix that. Write it as 3 over 25 minus 4 over 25. So what you do is you take each number in the numerator and then you put it over the 25 separately. Any question on that? The other thing, when you write it separately, they usually put the I just next to the entire fraction. You could leave the I in the top, but the I they usually just put next to the fraction. Don't put it in the bottom. Leave it next to it or leave it in the top. All right, so let's try one more divide. Okay, this one's a little bit more complicated than the last one because the top isn't a 1. So we are going to have a little bit of work we got to do on the top. Okay, so anytime we see a division problem, right away you want to think, I'm going to multiply by something. And what are we going to multiply by in this one? 5 what? Plus 12i. Yep. It's always the conjugate of the bottom. Don't ever do the conjugate of the top. Conjugate of the bottom. Okay, so 5 plus 12i. What are the two numbers that we're going to add up to get the bottom? So we're going to add, what are the two numbers we're going to add? 25 and 144. Yep. So except for just adding those two numbers together, we're done the bottom. Okay, that's it. 25 plus 144. Now the top, we have to distribute that up. So we'll start with 1 times 5 gives us how much? 5.
Wouldn't it be 144i?
Nope, the I cancels out. Whenever you multiply two conjugates together, all the i's are gone. So we're using that shortcut that we noticed. Okay, so we got 1 times 5. What's the next thing?
1 times 12i.
1 times 12i, which is how much? 12i. Okay, and the next two we're going to multiply together. How about Lucas?
4 times, 4i times 5,
Yep. And what's 4i times 5?
20i.
Good. 20i. And Kim, what's 4i times 12i?
48i squared.
48i squared. Yep. Okay. So now, bottom is 169. What about the top? What can I do there?
Combine like numbers.
Yep. And what would you get when you combine what you can?
5 minus 69.
5. And then what's 20i plus 12i?
32i.
So 32i. And what's going to happen to 48i squared? It's going to become negative 48. Okay, so we got that. Last thing we need to combine in the top is 5 minus 48. Yep, negative 43. So is this how we leave our final answer?
Yeah.
No, what do we have to do?
Negative 43 over 169 plus 32i over 160.
Yep, we're just going to split it so that 169 is over each number. So the real part is negative 43 over 169, and the imaginary 32 over 169. Okay, so on the test, I would expect to see at least one of each. One add, subtract, multiply, and divide. Okay. Any questions on that? Okay. So, last thing we're going to look at is section 5.3. So we'll do part of it today, and then we'll finish tomorrow. So the first thing we're going to look at in 5.3, we're going back to, eventually tomorrow, we're going to start looking a little bit at polar again, okay, where we write an angle and a radius. So you'll see the connection between what we learned on Monday and complex numbers tomorrow. And this is going to kind of build to that. All right, so what you're looking at here is called the complex plane. In the complex plane, it's very similar to the XY plane. There's two axes. The horizontal axis has been renamed, and so has the vertical axis. The horizontal axis is now called real, and the vertical axis, that is now called imaginary. As far as positive and negative, the directions are the same as what you're used to. Positive is right and up. Negative is left and down. So what I want to look at is graphing complex numbers. Okay, let's see if we can graph 2 plus 3i. If you can graph the point 2 comma 3, you can graph 2 plus 3i, because it's the same answer. So look at 2 plus 3i. What's the real part? 2. So that means on the real axis, which is the horizontal, you're going to go 2 to the right. What's the imaginary part? 3. So that means on the imaginary axis, you're going to move 3 units in the positive direction, because it's a positive 3. That's 3 units up. So 2 on the real, 3 on the imaginary, and that's how you graph the point 2 plus 3i. What's really important about that point is figuring out what quadrant it's in. That's the reason why I'm having you graph it. And you'll see why we need to know the quadrant in a little bit. And you can't switch the real and the imaginary axis. So that would be like switching x and y. If you switch them, it comes out backwards. So don't switch them. Okay, so let's graph that one. To graph 4, negative 8i, we would start at the origin and do what?
4 right down.
4 right, so go 4 units in the positive real direction, and then go 8 units in the negative imaginary direction. So that's 8 down. So we've got 4, let's see, 4, 8, I think is right there. So it's 4 minus 8i. Okay. How about negative 8? Lefty. Yep. So that's real. Negative 8 is a real number. So you're going to go 8 units in the negative direction on the real axis. Okay, that's right there. And what about 5i? Up 5. So that one doesn't have a real. If you want to add it, you can imagine it looks like that. So you're not moving in any direction on the real axis. You're going 5 units on the imaginary, and that is up. 1, 2, 3, 4, 5. Any question on graphing any of those points on the complex plane? So you have a couple of those on the test. You'll basically just click where you want to put the point, and then that's it. Drag the point anywhere you need to. It can be on an axis, or it can be in a quadrant. That's what I showed you here. Okay. So this is where we're going to start to see a little bit of the connection between what we learned in the first half of the week and what we're learning now. Is we're going to look at how we can take a complex number and write it in polar. So why not just write complex numbers the way we do? We already have this form. What's that format called? Standard. Right? That's standard form. Well, the reason standard form is kind of a pain is because of all that. Okay? If you want to multiply or divide complex numbers in standard form, there's a lot of steps. You got to find the conjugate. Even if you use that trick to simplify the bottom, that's fast. But then you're still going to FOIL out everything in the top. Then you got to combine like terms. Then you got to change I squared to -1, combine like terms again, and split it into 2 separate fractions. There's a lot of things that could go wrong there. If we know how to write complex numbers in polar, I can make all of these steps go away. Don't have to do any of that. But you have to know how to write a complex number in polar. So, but it does make what we just did much simpler. All right. So again, let's suppose we have a complex number, and I know that when I write a complex number, I normally write the I after the Y. I normally do it like this. It doesn't matter if you put the I before or after, technically, and I'm putting it before to try to match the formula that we're going to get in your book. That's why. Also, I've switched over from using A and B. The reason I'm switching is because I want you to think of this visually, and if I use X, I think you'll remember that that's horizontal, and if I use Y, you'll remember that number goes up and down. That's why I switched my letters. That is what we call rectangular, or you can also call standard. Might have used both words. The X is telling you how far to move left and right, and the Y is telling you how far to move up and down. So just look at a previous one we just did, 2 plus 3i. This is telling you left and right movement, in this case 2 right. This is telling you vertical movement, 3 up. When your directions are left, right, up, down, that is on a grid like this. That's rectangular or standard form. When we do things in polar, we don't use X and Y. What are the 2 letters we learn to use in polar? R and theta. So what we have to do is if you want to take a number that's a complex number and it's in standard form, that can't be there, and that can't be there. We need to get rid of those 2 things. Yep.
Can you? Okay.
Now, that's pretty easy to get rid of those 2 things. We already have formulas, if you remember from Monday. We had a formula that says X equals, and then we had something in polar. Does anyone remember what the formula was from Monday?
R cosine theta.
Yeah, we had X equals R cosine theta. And we figured that out on Monday by drawing a triangle. We went through it. And what was the formula we had for Y?
R sine theta.
R sine theta. So all we have to do to change that number into polar is take this and fill it in right there. Take that and fill it in right there. Okay, so let's fill those 2 things in. Okay, so now if I write it, I'm going to have R cosine theta plus, nothing's happening to the I is just staying right where it is. And then the Y is turning into R sine theta. Now, if you look at what I underlined there and there, what do they have in common in front of the trig function? They both have an R in common. When 2 things are being added or subtracted and they have the same thing in common, you can factor it out. So let's do that. If I factor an R out of this first term, what's left? Cosine theta. If I factor an R out of the second term, what's left?
What about G sine theta?
I sine theta. Yep. That is how you write a complex number in polar. So it's R on the outside, and then a cosine theta plus I sine theta. And that is a final answer. So let me make up a complex number in polar and show you what a final answer could look like. Okay, so these numbers I'm going to write down. I'm just making these up. Let's say r was 5 and theta was 30 degrees. 5 cosine 30 plus I sine 30. That's a final answer. You don't do anything with it. You don't take the cosine of 30. You don't distribute out the 5. You leave it just like that. Okay, so final answer always is going to look like what's in that box, except you fill in the value you get for r and fill in the value you get for theta. Now, how do we get r and theta? We already know that too. That's what we did yesterday. So when you're finding r, remember you'd have a point and you'd know 2 sides of your triangle. That's your r. What formula did we use yesterday to find r? Yep, we're going to use Pythagorean theorem. And then what function did we use to find theta? We had a certain formula in quadrants 1 and 4. And then we had a different one in 2 and 3.
The inverse of tangent times y over x.
Inverse tangent of y over x. Yeah, so no multiplication. Inverse tangent of y over x. So it's the same formulas we already know. So we're going to use them again. All right, let's try an example. So it says to take that and write it in polar. Okay, so that's a complex number. When I'm done, I'm going to have an answer that looks like what's in that box, but I need to figure out these 2 things. Let's start with finding theta. What is important to know about this point when you're trying to find your angle? You have to know something about that point. Well, what does your formula for the angle depend on? Because we have more than one formula, right? It depends on what quadrant it's in. We have 2 different formulas. So first thing we're going to do is take that point and we're going to graph it so we can figure out the quadrant. Okay, so graphing it, what quadrant is that point in? Yeah, it's going to be in quadrant 4. Positive, negative. I don't care exactly what that is as a decimal. Let's just say it's right there. Positive, negative. So quadrant 4. What's your formula to find theta when you are in the 4th quadrant?
Inverse tangent of y over x.
Yep. Inverse tangent of. And now, what number here? Remember, it's just numbers. We're not filling in anything imaginary here. What number would we fill in for y?
-1.
-1. That's the amount you went down. And what number would we fill in for x? Square root of 3. And it is important you put the -1 in the top. If you put it in the bottom, it's wrong. So make sure you put it in the top. Y over x. And if we want to get a nice answer, what unit should we do it in first?
Degrees.
Yep, so I'm going to do it in degrees. So inverse tangent of -1 divided by square root of 3. I didn't close my parenthesis, but it doesn't really matter. So theta is -30 degrees. Now, if they did say write your answer as a positive angle, what can you add to make an angle positive?
360.
You can always add 360 to it. So -30 is if you go this way. How much would it be if you went the other way? 330. Yep. Both answers are correct. It's just most of the time I think they're going to want a positive answer, not a negative. we talked about this in polar. There's 4 different ways we could write these answers. Okay. Well, we're going to try to stick with simple positive numbers. Okay, so we got the angle. So we got this part, which is the same as that part. What's the last thing we need? The radius. So the radius is from here to there. That's what we need to figure out. And what formula do we use to figure that out? Pythagorean theorem. Can you set up Pythagorean theorem for me using these 2 numbers?
Square root of 3 squared plus 1 squared equals
Square root of 3 squared plus what?
1 squared.
1 squared.
C squared?
Well, what are we solving for?
No, really R.
R. So let's use R squared. A lot of times you do use C squared in Pythagorean theorem.
Would it be a negative one or no?
No, because when you square it, it's going to go away anyway. So even if you put a negative there, that's fine, but it's going to cancel out. What's the square root of 3 squared? 3. And what's the negative 1 squared? 1. So what do we get for a radius? 2. Okay, so now we know the radius, and we know the angle, and let me show you how you write the final answer. So R cosine, and I'm going to go with the positive angle, so I'm going to go with 330. 330 plus I sine 330. That's how you leave your final answer. If you did this out, and you said, well, I'm going to take the cosine of 330 and then multiply by 2, what you'd be doing is changing it back to the original problem. So you'd be changing it back to what you started with. Okay? And same thing here. If you took the sine of 330 and multiplied it by 2 and then by I, you would be changing it back to negative I. Okay? So if you want to check your answer, you could do it out. But that's how you want to leave the final answer. Okay. Any question on that? So if you need the formulas again for theta, just look back in your notes from yesterday. It's either inverse tangent y over x or 180 plus inverse tangent y over x, depending on the quadrant. And if you're not in a quadrant, then you're on an axis, 0, 90, 180, 270. All right, so that's how you can write a complex number in polar. Now that we know how to do that, tomorrow I'll show you how we can make all of that go away using what I just showed you. But that'll be the last thing we do tomorrow. Okay, so homework for tonight. The page 560, that's on the multiplying and dividing complex numbers. The 15 to 27 is odd. 28 is the only question for tonight. The page 333, that's on graphing. I think each question has 3 parts on the 11 to 19. Let me double check. Two parts. First part is for 11 to 19, graph the number. And then the second part is write it in polar. So it's exactly what we just did on this last problem. Graph it, write it in polar. Okay, so we'll take a look at that tomorrow. Reminder, I'll be after school tomorrow for extra help. And grades are all done, so you should be getting your report cards, I think, tomorrow or Friday. Okay. Those should be getting to by Friday.